Look at the world around you. Look at the chair you are sitting on. Look at the walls of the room. Look at the screen you are watching this on. Now look at your own hand. Turn it over. Watch the light catch the texture of your skin. Everything you see, solid, liquid, gas, plasma, is made of atoms. And the outside of every single atom, the shell that gives it size and texture, and the ability to touch other atoms, is a cloud of electrons, trillions upon trillions of them. Now, I want you to ask yourself a question that is so simple, most people never bother to ask it. A question that seems trivial, but actually tears at the fabric of reality. Why are they all identical? Think about it. In the biological world, no two things are exactly the same. No two fingerprints, no two leaves on a tree, no two zebras have the same stripes. Even in the world of manufactured objects, no two cars coming off an assembly line are truly identical. One has a microscopic scratch on the bumper. One has a slightly tighter bolt in the engine. One has a few more atoms of iron in the door frame. Diversity is the rule of nature. But electrons, if you take an electron from the apple you are eating and you compare it to an electron from the core of a star 1 billion light years away, and you compare that to an electron that existed 1 second after the Big Bang, they are identical. They have exactly the same mass, down to the last infinite decimal point. They have exactly the same electric charge. They have exactly the same spin. You cannot tag them. You cannot paint them. You cannot scratch them to tell them apart. If you swap them, if you replace every electron in your brain with electrons from a rock, the universe literally does not know the difference. Your thoughts would continue without a glitch. Why? Why did the universe decide to mass produce $10 to $80 identical copies of this one specific particle? Did it use a mold? Did it use a cosmic 3D printer? If you have a factory making billions of items, eventually the mold wears out. Eventually, there is an error. But in 13.8 billion years, the universe has never made a mistake. There isn't a fat electron. There isn't a skinny electron. There is only the electron. In the spring of 1940, a young Richard Feynman was working on his PhD at Princeton University. He was a brilliant, arrogant, energetic young man, but he was struggling. He was wrestling with the mathematics of electrodynamics, the study of how light and matter interact. The equations were messy. They didn't seem to make sense. He was trying to solve a problem about why particles radiate energy, and he was hitting a wall. And then the phone rang. It was his professor, the legendary physicist John Archibald Wheeler. Wheeler was a wild thinker, a man who wasn't afraid to propose ideas that sounded completely insane as long as the math worked. He didn't say, "Hello." He didn't ask, "How are you doing, Dick?" He opened the conversation with a sentence that would change the course of human history. He said, "Feynman, I know why all electrons have the same charge and the same mass." Feynman, holding the phone, probably rolled his eyes. He asked, "Why?" And Wheeler replied, "Because they are all the same electron." Let that sink in for a second. Wheeler wasn't saying they were similar. He wasn't saying they were copies. He wasn't saying they came from the same factory. He was saying that every single electron in your body, and every single electron in the sun, and every single electron in the entire observable universe is the same object. There is only one, and it is zipping back and forth through time so fast, crossing its own path so many trillions of times, weaving such a complex knot through the history of the cosmos that it creates the illusion of billions of particles. You think you are made of trillions of particles, but in reality you are just a box containing one single particle that is visiting you trillions of times at the same moment. Today we are going to explore the one-electron universe. We are going to look at the Feynman-Stueckelberg interpretation of antimatter. We are going to dive into the math that suggests time is not a one-way street. It is a road, and sometimes, to get where you are going, you have to drive in the wrong direction. To understand this, we have to start with a map. We have to understand the difference between matter and antimatter. Imagine you are a general standing on a hill, looking down at a map of a massive battlefield. You look down and you see a line of soldiers marching. They are all wearing green uniforms. They are all marching north toward the future. We call these soldiers matter, electrons. They carry a negative charge. They move forward in time. This is what you are made of, Now imagine you look at a different part of the battlefield. You see another group of soldiers, but these soldiers are weird. They are wearing red uniforms, and they are marching south toward the past. These soldiers are antimatter, positrons. They have the opposite charge, positive, and they seem to act as the evil twins of electrons. If a green soldier touches a red soldier, they annihilate each other in a flash of light. For years, physicists thought these were two different species of particles. God created the electron, and God created the positron. They are enemies. They are opposites. They are eternally separated by their nature. But Feynman looked at the math, and he saw something strange. He looked at the Dirac equation, the formula that describes how electrons move. He realized that the variable for charge and the variable for time were linked in a very specific way. If you take the equation for a green soldier, electron moving forward in time, and you force the variable time to be negative, essentially playing the movie backward, the equation doesn't break. It doesn't give you an error message. Instead, it transforms. The negative charge flips to a positive charge. The forward motion flips to backward motion. Mathematically, a negative charge moving backward in time looks exactly, and I mean exactly, like a positive charge moving forward in time. Feynman realized that the red soldiers marching south might actually be green soldiers marching backward. The positron might not be a separate particle at all. It might just be an electron that is turned around. Let's visualize this with a more familiar analogy. Imagine you are watching a movie of a car driving down a long, straight highway. The highway represents time. The car is the electron. It is driving from Monday to Tuesday. This is normal life. Now imagine the car hits a patch of ice. It spins out, it drifts, it whips around 180 degrees. Now the driver slams on the gas, but he is facing the wrong way. He is driving from Tuesday back to Monday. He is driving against traffic. Then a few miles back down the road, he hits another patch of ice. He spins around again. Now he is facing forward again. He drives from Monday to Tuesday. If you watch the whole movie from a helicopter, you would see one car doing a zigzag, forward, backward, forward, a giant letter N drawn on the highway. But now, imagine you can't see the helicopter view. Imagine you can't see the loops and the turns. Imagine you are standing next to the highway behind a tall fence. There's a single vertical slit in the fence. You can only see a tiny slice of the road at one specific moment, let's say 12:15 p.m. What do you see through the slit? You see the first section of the car driving past you going forward. That's an electron. Simultaneously, a few yards away, you see the middle section of the car driving past you, going the wrong way. That looks like a positron. And simultaneously, a few yards further down, you see the third section of the car driving forward again. That's another electron. You, the observer trapped in the present moment, think you are looking at three different cars. Two cars going forward, one car going backward. You think you're seeing three particles. You create a theory of car conservation. You say, look, there are two matters and one antimatter, but you aren't seeing three cars. You are seeing one car, crossing your line of sight three times. This is the zigzag theory of reality. When physicists see an electron and a positron collide and annihilate, releasing a burst of energy, we usually think of it as a violent death. Two particles entered the ring, fought, and destroyed each other. We write equations for the creation and destruction of matter, but Feynman says, no, that isn't death. That is a corner. The electron was traveling forward in time. It hit a patch of electromagnetic turbulence, usually a photon. It got knocked so hard that it spun around in the temporal dimension. It started traveling backward into the past. To us, watching the movie forward, it looks like the electron disappeared. And simultaneously, a positron, which is just the electron traveling backward, walked into the annihilation point and also disappeared. The flash of light is just the energy released by the braking maneuver, but from the electron's perspective, it never died. It just turned around. It didn't feel an annihilation. It just felt a bump. It traveled back to the beginning of the universe. Then maybe it hit the Big Bang, bounced off, and started traveling forward again. Now let's go back to Wheeler's phone call. Wheeler took this idea, this simple geometric trick, and he took it to its logical, insane extreme. He said, Feynman, imagine the knot is huge. Imagine the highway isn't just a few miles long. Imagine it covers the entire universe. Imagine that this single electron started at the singularity of the Big Bang. It traveled forward through the chaotic plasma of the early universe, through the formation of the first stars, through the birth of the galaxies, all the way to the heat death of the universe trillions of years in the future. Then at the end of time, it hit a boundary. It hit the final wall of entropy, and it bounced. It did a U-turn. It became a positron. It traveled all the way backward through 100 trillion years of history, passing through galaxies in reverse, watching stars unexplode until it reached the Big Bang again. Then it turned around again, and again, and again, back and forth, past to future, future to past, weaving a tapestry that covers the entire cosmos, trillions of threads, quadrillions of zigzags. If you take a slice through this tapestry, which is what we call today, this specific moment in time, you would cut through that single electron's world line trillions of times. Half the time you would catch it on a forward leg of the journey. You would call those electrons. Half the time you would catch it on a backward leg of the journey. You would call those positrons. This explains perfectly why every electron is identical. Of course they have the same mass. Of course they have the same charge. Of course they have the same spin. They aren't copies. They are the same object, visiting us at different points in its eternal journey. The electron in your left hand is the same electron that is in your right hand, just a few billion years older or younger. It is a beautiful theory. It is elegant. It solves the problem of why is everything the same. It unifies matter and antimatter into a single geometric shape. It makes the universe feel connected in a way that nothing else does. But there is a problem, and Feynman, being the skeptical genius he was, spotted it immediately on the phone call. He listened to Wheeler's pitch. He imagined the giant knot, and then he said, "But Professor, there aren't enough positrons. Think about the highway analogy again. If the car zigzags for every backward section, there must be a forward section. The loops are continuous. They come in pairs. If the universe is one electron going back and forth, then for every electron we see forward, we should see a positron backward. The universe should be 50% matter and 50% antimatter, but it isn't, not even close. We look around. The Earth is made of electrons and protons. The sun is made of electrons and protons. Your body is made of electrons. Where are all the positrons? Where is the antimatter? We know it exists. We create it in particle accelerators like the Large Hadron Collider. We see it in cosmic rays falling from the sky, but it is incredibly rare. If the universe were 50% antimatter, as soon as you tried to drink a glass of water, the electrons in your lips would touch the positrons in the water, and boom, you would vanish in a nuclear explosion larger than the Tsar Bomba. The fact that we are sitting here alive proves that matter won the war. Matter dominates the universe. Wheeler was stuck. The math demanded symmetry. Observation showed asymmetry, but Wheeler was a quick thinker. He didn't miss a beat. He replied, well, maybe they are hidden in the protons. He suggested that maybe the backward-moving electrons somehow disguise themselves as protons, which have a positive charge. Now, we know today that isn't true. We discovered that protons are composite particles. They are made of quarks. They are huge compared to electrons. They are not just hidden positrons. So the one-electron universe theory, in its literal physical form, probably isn't true. The numbers don't match up. The balance sheet of the universe is lopsided. But the zigzag part, the idea that antimatter is just matter moving backward in time, that part stuck. That part survived. In fact, it didn't just survive. It became the foundation of quantum electrodynamics, QED. It became the standard way we calculate reality. When physicists today sit down to calculate how atoms interact, they use Feynman diagrams, little cartoons that represent the math. And in those diagrams, when they draw a positron, they literally draw an electron with an arrow pointing backward in time. It works mathematically. It works experimentally. If you treat antimatter as time-reversed matter, the equations of the universe solve perfectly. This leads us to a philosophical cliff, a cliff that makes us question the nature of our own existence. If an electron can move backward in time, what is time? We human beings experience time as a river. It flows in one direction. It drags us from birth to death. We remember the past, but we cannot visit it. We anticipate the future, but we cannot see it. We are trapped in the now, moving forward at a rate of 1 second per second. We cannot stop. We cannot turn around. But an electron is not a human. To an electron, time is just a dimension. It is just like north or up or left. If you are walking north and you realize you forgot your keys, you can turn around and walk south. To an electron, if it is moving tomorrowward and it hits a photon, it can simply turn around and walk yesterdayward. It implies that the past is not gone. It is just down the road. It implies that the future is not unwritten. It is just up the road. The road exists. The entire landscape of time, past, present, and future, exists simultaneously as a solid block. The electron can walk it in both directions. So why can't we? Why are we trapped in the forward direction? If we are made of electrons, and electrons can time travel, why can't we time travel? The answer lies in complexity and entropy. An electron is simple. It is a point. It has no memory. It has no internal parts. It creates no entropy. When an electron reverses time, it doesn't have to unbrake anything. It just changes coordinates. It is like a single car on an empty desert highway. U-turns are easy, but you are a complex machine. You are an entropy engine. As we discussed in our video about the arrow of time, you are constantly breaking things. You are turning food into heat. You are scrambling eggs. You are creating disorder. You are a traffic jam of a trillion cars, all speeding down the highway at once. For you to turn around in time, you wouldn't just need to change direction. You would have to unscramble the eggs. You would have to unburn the calories. You would have to coordinate a trillion particles to all do a simultaneous U-turn without crashing into each other. You are fighting the statistical probability of the entire universe. The electron is a pedestrian. You are a freight train. The pedestrian can turn around. The train cannot. But deep down, inside your atoms, the U-turns are happening. Right now, inside your body, there are radioactive potassium-40 atoms decaying. Every once in a while, they spit out a positron. For a brief fraction of a nanosecond inside your own DNA, a piece of the universe is traveling backward in time. It travels backward, it hits an electron, and it annihilates. A tiny spark of gamma radiation is born inside you. The dance of time is happening within you, even if you are too big to feel it. This brings us back to the one electron. Even if the universe isn't literally one single particle, the idea destroys our concept of individuality. We like to think we are separate. I am me. You are you. That electron is over there. This electron is over here. We build our identities on separation. But in quantum mechanics, separation is an illusion. If two electrons are identical and you smash them together and they bounce off, you cannot say which one came out. Did electron A bounce off electron B? Or did electron A turn into a positron, go backward in time, become electron B, and loop around? The math says you must treat them as if both happened. You must sum over all histories. The identity of the particle dissolves. There is only the field. There is an electron field that permeates the entire universe. It is a single vibrating ocean. What we call a particle is just a wave on that ocean. And just like you can't distinguish one wave from another, they are all just water, you can't distinguish one electron from another. They are all just field. In a deep sense, Wheeler was right. They are all the same thing. They are all ripples in the same cosmic fabric. The distinction between this one and that one is a lie told by our limited senses. So the next time you feel lonely, the next time you feel small, the next time you look up at the stars and feel insignificant, remember the one electron. Remember that the stuff you are made of is not just dead matter. It is an ancient traveler. It has been to the beginning of time. It has been to the end of time. It has looped and zigzagged and danced through the void for eternity. And for this brief shining moment, billions of those loops have tied themselves together to form a knot. And that knot is you. You are not just an observer of the universe. You are the universe, playing a game with itself. You are the green soldier marching north. You are the red soldier marching south. You are the car doing the U-turn. You are the knot in the fabric of space-time. And one day, the knot will untie. The electrons will go their separate ways. Some will go forward to the heat death of the cosmos. Some might turn around and go back to the Big Bang. But the dance never ends. Physics tells us that matter cannot be created or destroyed. But Feynman tells us something more beautiful. He tells us that matter is just a pattern in the loom of time, and the pattern is infinite.